Hello and welcome. My name is Henrik Bendsen. I am product manager for our Jofra temperature calibrators here at AMETEK. We develop, we manufacture, and we distribute the Jofra temperature calibrators. I want to welcome you to our webinar about how to effectively calibrate sanitary sensors. Just a brief introduction about myself and Jofra before I really get started. I have worked with our Jofra product line both as an area sales manager and as a product manager for more than 30 years. Part of my job as a product manager is to continuously work with our customers and R&D to develop high-performing temperature calibrators. We strive to develop calibrators that deliver high accuracy, are easy to carry, and that are intuitive to use. At Jofra, we believe that you need to be innovative and a first mover in order to make good products. On this slide, you will see just a few of our important milestones in the development of our temperature calibrators. Among the many highlights, note that we did in fact invent the dry blocks, which later became a global market standard. Then we had the invention of the dry blocks designed for sanitary sensor calibration, namely the RTC156. Then we come to our latest invention, a calibrator that gives you 4 solutions to calibrate sanitary sensors, both wet and dry. All of the mentioned highlights are industrial first inventions. Today, I'll be using our last invention as a base for my presentation. The new wet and dry calibrator for sanitary sensors is called RTC168, and I will be referring to it later in this webinar. The RTC168 was invented after I gathered a group of customers within the food and pharma industry. They all gave me their input to what the optimal calibration solution would be if we were to invent a calibrator for their sanitary sensor calibration needs. The RTC168 is a great example of how the Jofra products are always developed based on actual market needs. And now to the agenda for today. Calibrating sanitary sensors is not a straightforward calibration, so I will discuss what is the most common problems when calibrating sanitary sensors, what to consider when calibrating sanitary sensors, or in other words, what shall I do to perform the best possible calibration? Now that we know that it's difficult to calibrate sanitary sensors, what does that mean for the accuracy we can actually obtain? What calibration method would be the best to use, wet or dry calibration? We will show a practical example of how to use the RTC168. The most common problems when calibrating sanitary sensors. Short sensor length. Since these sensors are short, we cannot get the sensor under test down into the homogeneous zone of the calibrator. Large heat conduction out of the calibrator due to the big thermal mass of the sanitary clamp, meaning that the heat is going the wrong way. In other words, the heat is going out of the sensor instead of going into the sensor. This leads to an inherent measurement error just due to the sensor design, meaning that we have all odds against us performing these calibrations, since the sensor itself tends to create a measurement error. Too big sanitary clamp diameter to get into the calibrator. And that simply means that the calibration is impossible in many calibrators. You therefore have to carefully examine if the calibrator can accommodate the sanitary claimed diameter of your sensor. Repeatability. Due to the fact that it is very difficult to place the sanitary sensor as well as the needed reference sensor in the same position for successive calibrations. Transmitter error, temperature drift, due to the heat exposure of the transmitter, meaning that the transmitter will also influence the results. Sensor not perpendicular to the sanitary clamp. This can cause bad thermal contact between the sanitary clamp and the insert. Using wet calibration could be a good solution here. What to consider when calibrating sanitary sensors? Well, always use external reference sensor, and that is in order to have it positioned close to the sanitary sensor. Always position the reference sensor and the sensor under test at the same depth when calibrating dry. And this is in order to minimize, hopefully eliminate, error from axial inhomogeneity. Always use external waterproof IP68 reference sensor when calibrating wet. And that is, of course, in order to protect the reference sensor so we can calibrate with stability and accuracy. Use the set follows true function. The set follows true shall always be activated when performing sanitary sensor calibration. Set follows true SFT, that means that the reference sensor now serves two purposes. Naturally, it is a reference and at the same time being the controlling sensor. That means always use a calibrator with input for an external reference sensor. Be aware that a transmitter can actually influence the result due to its temperature sensitivity. Ideally, the transmitter should not be integrated with the sensor. Then you should always be realistic about what accuracy is needed. No matter how good your calibrator is, or even if you calibrate the sanitary sensor in a laboratory bath, you cannot expect the same results as you can when calibrating straight sensors. Make sure to have the biggest possible contact area. Also, make sure to have the best possible contact between the sanitary flange and the insert. In both cases, that is in order to have as much as possible energy transferred from the insert to the sanitary sensor. The rule goes, the better the thermal contact, the better the calibration result will be. What accuracy can you actually expect when calibrating sanitary sensors? I think that we all know that the best way to calibrate a sanitary sensor is by using a laboratory bath with a huge heat capacity and a good flow. But first, let's take a look at the physics. What happens when calibrating a sanitary sensor or measuring with a sanitary sensor? As an equivalent to Ohm's law, we have the thermal law. As you can see, T1 minus T2 is the, so to speak, thermal voltage, and Q is the thermal current, the heat conduction. That means whenever T1 is different from T2, we will have a heat conduction out of the sensor, a heat loss. This loss will cause an error. In a way, you could say that the sanitary sensor itself have an inherent error, a built-in error. That again means, so even if calibrating in an ideal laboratory bath, there will still be an error due to the sensor itself. The heat loss, the heat will go out of the sensor instead of going into the measuring element, the PT100. The 15 times diameter rule is impossible to imply with these short sensors. The rule states that the immersion depth of a sensor should be 15 times the sensor diameter in order to eliminate measuring error. This rule is not possible to obey with sanitary sensors. The thermal mass and thus the heat conduction out of the sensor is significantly larger than that of a straight standard sensor. So even with our best effort to calibrate a sanitary sensor, there is an inherent measurement error in the sensor itself. Different sanitary sensor designs will therefore cause errors of different magnitude. The error is impacted by, well, first of all, the thermal potential, meaning the difference in temperature between the measured and the ambient temperature. Then also the mechanical design of the sensor, and that is sensor length, thermal mass, and clamp diameter. With that said, it is impossible to state an exact accuracy of a temperature calibrator when calibrating sanitary sensors. So the best way to describe the accuracy of a sanitary sensor calibrator is to compare the result with that of an ideal calibration, namely in a laboratory bath. Now we compare our RTC 168 calibrator result with that of a true calibration in a laboratory bath. We have made a very thorough test. We have performed a whole matrix of tests. 5 different sanitary sensors have been calibrated with 3 different calibration methods. And the 3 different methods are calibrated in a special design insert, in an adapter with RTC 156 sanitary clamp, and finally in a bath. So relative to the true calibration in a bath, we find that the average error at the low temperature, -10 degrees, is 0.058. And the average error at the high temperature, 160 degrees, is 0.073. Furthermore, I have searched to find a pattern to recommend a special calibration scenario for certain types of sanitary sensors, but there is no such pattern. That brings me to 2 conclusions. Conclusion number 1, the RTC 168 gives good accuracy compared to that the best possible calibration. Conclusion number 2, you can choose the calibration method suiting you the best. How do I most effectively calibrate my sanitary sensor, wet or dry? Remember, we just concluded that no calibration scenario is better than the other. The next 2 slides are just describing advantages of wet and dry calibration. These should help you to make your choice between wet and dry calibration for your sanitary sensor calibration. So first of all, here are the advantages for wet calibration. You can calibrate any type of odd-shaped sensors. Oil and water fits all. You can calibrate sensors that wouldn't fit in an insert. That could be a conical sensor or a bulb sensor. You don't have to have a whole suite of inserts to fit all of your sanitary sensors. You have very good axial uniformity due to the heat conveyor and the fast steering. Very good horizontal uniformity, very small influence from load, and you can calibrate at once, meaning that you do not have to wait for design of special sanitary inserts. And here is a list of the advantages for dry calibration. Easy and fast setup of the calibration, 100% repeatability due to the fixed sensor positioning in the insert, no hazardous hot liquids potentially causing hot burns, no polluting oil vapor, no oil contamination of the sensor under test, no need for time-consuming cleaning of the sanitary sensor after calibration, and no need for external exhaustion. Now with these lists of advantages for both wet and dry calibration, you can choose what calibration would suit you the best. I have created some videos that show the 4 different ways you can use our new RTC168 calibrator. They can all be found in our YouTube channel and on our website. But here is, first of all, a short video showing how fast that you can switch from wet to dry calibration with the RTC168. Please note here, there is no time spent on cleaning. The purpose of designing this special container is that our customer wants that we can make a very fast switch from wet to dry calibration. So now we can just take out the wet calibration, no contamination, no time for cleaning the calibrator. Just make ready for the dry calibration. Very simple and easy like that. Take the insert, put in the reference sensor, put the sensor on the test on the top, and then we are ready to calibrate. But for safety, we have also made this lid to put on the container, so now we can transport that safety. Now we are ready to do dry calibration. This is the fastest switch you can do from wet to dry calibration. The RTC168 is the solution to sanitary sensor calibration. The RTC is a dedicated sanitary sensor calibrator. It can perform both wet and dry calibration of sanitary sensors. It performs high-speed calibration due to the larger enhanced heating capacity. The RTC168 deals with common sanitary sensor calibration issues. And on top of being a dedicated sanitary sensor calibrator, the RTC168 can naturally still perform calibration of standard sensors and take many sensors in a run. Now we are back to the list of common problems when calibrating sanitary sensors. Let's go through the list and see how the RTC168 solves the problems. The RTC can solve the 5 calibration-related problems. Only the 2 problems coming from the sensor design can naturally not be compensated. Short sensor length. For both wet and dry calibration, this is compensated by using our short reference sensor positioned at the same depth as the sensor on the test in combination with an active top zone temperature control. Large heat conduction out of the calibrator due to the big mass of the sanitary clamp. This heat loss is compensated by enhanced energy, fast stirrer speed, and the patent-pending heat conveyor. 2 big sanitary clamp diameters to get into the calibrator. The RTC168 have been designed with a special top, making it possible to accommodate up to 84 mm sanitary clamp diameters, both wet and dry. And this covers the majority of sanitary sensors. Repeatability, performing wet calibration. The repeatability is secured by having the sanitary sensor being in a fixed position by the use of the patent-pending heat conveyor. Sensor not perpendicular to the sanitary clamp, then the design of special insert can be difficult. But with the RTC168, one of the 2 wet scenarios can then be used. You can find more literature about this subject on our homepage. And this actually concludes the webinar about sanitary sensor calibration.